This is section 2.7, and we're going to talk about inverse functions. One thing I wanted to share with you, this is some scribble from earlier, so let me erase this slide. Okay, so one thing I wanted to share with you is the inverse of a function is when the x and y literally change places. So say this is f of x, then f of the function, the inverse of the function, which is denoted as f to the negative 1, is going to be reversed. The y and the x change places. So just to give you that first part. And also, I do want to mention to you before we get very far in this, don't confuse use of -1 to denote the inverse of the function, because f of 1 is always referring to the inverse. It's not like a reciprocal where, if you have x to the -1, you would have 1 over x. That is not the same thing in this situation. So when it's dealing with a function, it is literally just saying it's the inverse, not the reciprocal. Okay, I want to make sure that you guys understand that before I go on. All right, so let's go back. Okay, so on this first function, we have f of x equals x plus 4. Okay, and here's what our output of our function is. Now, if I go on and make the inverse of that, remember I told you it is literally just reversing the x and y's. So look at this, 5, 1. The first one was 1, 5. This is 2, 6, so the next one will be 6, 2. So notice that the x and y's are reversed. Now, the other thing I wanted to point out is how to algebraically solve to find a function. So if we know that f of x is x plus 4, if I wanted to solve this algebraically to find the reverse of the function, I am literally going to trade the places of x and the f of x. So this will become x, and I'm going to call it f of -1x, by the way. And I'm going to solve for f of -1x by subtracting 4 from both sides. So I have x minus 4 equals the inverse of x, f of x. So, and that's what they gave us here. So anytime you are wanting to solve to find the inverse of any function, you can take the inverse of it and solve for it. Okay. The next thing I wanted to point out to you is when you have the inverse of the function, you can actually take the composite of the original function and its inverse, and you'll find that that composite ends up always being x. The same is true in the reverse. So I could take the inverse of the original function f of x, and when you solve it, it becomes x. I don't know if this clearly shows this to you, so let me just kind of walk you through it. So if I have f of x is x plus 4, and I know the inverse of f of x is x minus 4. Remember, when we're taking the composite, we're taking, so if I do f of the inverse, I'm taking this and I'm plugging it in for x right there. So I will end up with x minus 4, because I'm plugging that in for x, plus 4, and those 4's cancel out like they do up here. Same thing in reverse. If I'm going to input f of x into the inverse function, that means I'm going to take this and plug it in for this x, and that's how they get this. All right, so I have some scratches here. Let me erase all those. All right, so first of all, let's look at even solving this for its inverse function. If I have f of x equal to 4x, let's reverse those places. So I'll have x equals 4 f to the -1 of x. And I need to solve for the inverse of f. So I'm going to divide both sides by 4. So now I know that my inverse is going to be x over 4. Now, if I want to check to see if this is indeed the inverse of the original function, I know that if I take the composite and then the reverse composite, they should both equal x. So let's try that out. Remember, my first one is 4, and I'm going to replace this x with this inverse of x. So that will be x over 4. The 4's cancel, and I'm left with just x. So far, so good. Let's do the other one. Let's do the negative one. So x of x. So remember, this time, we're going to take this function here, and we're going to plug it in to this x. So that will be 4x over 4. The 4's cancel, and I'm left with this x. So we've just proven that both of these functions are inverses of each other. So in the end, here is the definition of the inverse of a function. You know that they are inverses of each other if you can make a composite of them and they end up with just x and just x also in the inverse composite. And so they must be inverses of each other that way. Also, here's one little bit of information that I think is kind of interesting that you may want to know is this. The domain of f must be the same as the range of the inverse. Remember, I told you at the very beginning, we're literally just switching the x and y's. So for f of x, we know that the x's are the domain, right? And the y's are the range. Well, the inverse is true for f of negative 1 because remember we switched our x's and y's? So they're like this. So our y's are the domain and our x's are the range for the f of negative 1. So the domain is equal to the range of the inverse. The range is equal to the domain of the inverse.